Page 85 is where I'll be. Anyone else need the packet? You're good? So we will indeed still offer you the opportunity after a test or quiz to come in and earn half your points back. Okay, I think that was very beneficial for the students in the class. Okay, there were some of you where I was saddened who had like 76% once we were all said and done, and that student never once came in. You want to know what that 76 could have been? It could have been a B. Sit where you want. Open seating. And we're on page 85. If you tossed it, you can grab this packet here. We're on page 85 in the book. If you need it, I have chapter 4 there if you recycled everything. If not, it's okay. That packet right there. Yeah. Okay. So again, the coming in and earning half your points back is a huge benefit, because I know that some of you, if you didn't do that, might not have had quite the marks that you had. And I love the marks that we had. I love the fact that when I took a look at my grades between first and second period, between the two classes, we had at the end of the semester an average grade of an 85%. That's awesome. That's a huge testament to all of you. Okay? But, so to kind of keep the fire lit a little bit, you will have 10 school days after any test or quiz, once it's posted in the grade book, to get that, make those points up. Okay? Just so I don't have to run into someone coming in, 2 or 3 days before the end of the semester saying, hey, can we go over all my tests and quizzes? Yes, I guess. Okay, so it was kind of put a little strain on me a little bit, so I just want to hold you a little bit more accountable. I mean, most of you are doing fine, and I get it. I'm not going to point out the person who came in and wanted to do everything, towards the end. Yes, it did improve their grade, which was good. So I was happy about that. But I just wanted you to do that. Now, you are my seniors. Okay? This is your last, basically, 5 months of public education. What are the choices to do after? There's all kinds. Some of you will choose to go to college. Some of you will choose to do a gap year. Some of you will choose to go into the military. Some of you choose to go to work. What's the right decision? Whatever your decision is the right decision. Okay? But how do you want to spend this last 5 months? Okay? So we had January, February, March, April, May, right? Basically mid-May we're done. So some things that I wanted just to not punish or anything. I just want to enlighten. I know that some of you spent more time on social media and other things on your phone than did in class. Is that really how you want to end high school? Saying, I made it through Stirrups class by just seeing all the latest and greatest. If that's your choice, that's your choice. But I would ask, just person to person, adult to adult, is that really what you want to do? I mean, there's some really great stuff that this statistics is offering. Some people might ask, is second semester a tougher semester than first? No. It's different. There's definitely things that we're looking at that are different, but it's where it is. So with statistics, so far we've talked about like average, and we've talked about median. So we've talked mean and median. We've talked about standard deviation. We've talked about quartiles. We've talked about box and whiskers, where you have Q1 and Q3, and you have the min and the max, and the medians in the middle. Okay, we've talked about all these kind of things. And then we talked about, hey, is our data acceptable by what we know? Okay, we've basically gone over 2 different ways to look at things being acceptable. Okay, we're going to get into more stuff to have more ideas of how we would then start satisfying that, statistically speaking, something that we look at is a viable thing to say, yes, this is what we want to accept, or no, we don't want to accept, and this is why. Now, we're still going to use Desmos. Okay, so if you deleted that off your phone, make sure you reload it. Okay, I think Desmos is a real powerful tool for you. I actually, on my cruise, because I'm just such a math geek, I saw 2 people on the cruise with Arizona State shirts on. Hey, they're after my own heart. I went to Arizona State. Didn't graduate from there, but I went there for 3 years. I went over and said, hey, it's nice to see a couple of Sun Devils. And they were both professors. One was a professor of economics, and one was a statistics professor. And what made me giggle, and because I took statistics at Arizona State, she says to me, yeah, I have 900 students a year, and they all hate me. And I thought, well, that's where you need to look in the mirror as being a teacher, because if you have 100% of your students hate you, I didn't say that to her, but I just thought it. I said, I got like 1 kid out of my 60 students I have that probably hates me. The rest probably think I'm a rhinestone cowboy. But those are just they're just kind of fun conversations. But it was funny because she, obviously, having a PhD in statistics, has a larger understanding of statistics than I do. But we're kind of going back and forth, joking about statistics. And I said, I gave her my worst math statistics joke. I said that 3 out of 2 people in the world don't understand mathematics. And she's probably the only person that understood that. And that's kind of me being a geek. And then I went back and got a sandwich and a nice cool drink. Not saying what the drink was, it was just nice and cool. And then sat there with the rest of my family. As we were flying from Fort Lauderdale, Florida, back to Dallas, and then Dallas to here, our flight from Fort Lauderdale, Florida, had 30 people in wheelchairs. An hour and a half to load the plane. And I'm thinking, okay, this stinks. If any of these people in wheelchairs are in the emergency exit aisle, I'm going to have an issue with this. Because I'm going to step on that person to get over them to get out that door if I need to. So, now the nice thing is we landed Dallas, guys. We're taxiing to get to our gate to transfer planes. They come over to the PA and said, ladies and gentlemen, 30 of you have requested a wheelchair to pick you off this plane. We don't have enough. If you're in a wheelchair and need wheelchair access to get off the plane, stay seated. We will deboard the entire plane and then get to you. There was a big applause. Not that we had to get to our plane right away. We still had a little bit of time, but it was like one of those going, I got 10 minutes to make it to gate E. Yeah, that was kind of bad. So anyhow, let's start on page 85. We're going to look at something that goes very importantly with statistics, and it talks about probabilities. Okay? So the main thing to understand about probabilities, it can go between 0% and 100%. Okay? That's using it as percents. Or it could go from 0 to 1. Okay? This is not percents. Okay? There's 2 different things, right? Pretty easy so far. So something when I'm in job interviews, interviewing potential candidates, one big flag for me, and I won't hire a person just based on this one statement, is this. I'll give 110% to what I do. Thank you very much for coming in. Have a nice day. We'll call you. You don't call us. You can't give 110%. It's a ridiculous thing. It's something that people trying to glorify what they're going to do. You know, what should someone say? You know, that I'm going to work as hard as I can. I'm going to work as hard as I can to improve this. I'm going to work as hard as I can to do this job to the best of my abilities. Those are all wonderful things to say. Saying, I'm going to give 110%. Really? There's 24 hours a day. So you're going to give 110% of a day. So now you're talking about 26.32 hours a day. You're going to work for us? That's amazing. How did you change the orbit of the earth going around in circles? Okay? And this is sarcasm on my part, but it's also serious. So those of you who are choosing to get jobs, please refrain from the statement, I'll give 110%. Because you're not. I'm not saying that you're not going to work hard, but you're not going to give 110%. Yeah. Yeah, a little bit. Yeah. But it also means you've already lied to me in the first 3 sentences of the statement. What else are you not going to be truthful? Hey, welcome back. So we're on page 85. If you got rid of chapter 4, you can come get one of those. Cool. Yeah. So there's a lot of silliness that this guy does, but there's a lot of stuff that's all seriousness of why I do things the way I do. Okay? No, I'm not going to say I'm going to give 110%. That's impossible. Okay? Does that make sense? And I know some of you are like, oh, it kind of makes you a big jerk, Stirrup. Yeah, I know. But calling a liar out a liar. Okay, so if you have a 0% probability of something taking place, guess what? It won't happen. The event. Okay? What's the probability that it's going to be 105 degrees today in Denver? It's not going to happen. The probability is 0. Okay? Could we have some weird Mother Nature dorky thing that takes place? Sure. But I know Dave Aguilera, my neighbor on News 4, weathercaster, he's always wrong. But I can't say that he's been that wrong to say, you know, it's supposed to be 50 today, and then all of a sudden you guys go outside around 2 o'clock today going, man, it's 105 degrees. Guess there was a chance. Okay? If an event has 100% probability of happening, it will happen. Okay? Mr. Stirrup will use sarcasm at least once in today's lecture. Probability of that happening? 100%. You will definitely get sarcasm from me. Hey! Thank you very little. Gotcha. Cool. Thank you. Thanks, brother. All right. So now let's go with some events. So the probability of something taking place. So when you see P and then parentheses X, this means P at X. So P means in statistics that you're going to deal with probability. Probability and then event. So you get a probability of rain, probability of snow, probability of winning the lottery. Yes, I understand the Powerball is quite impressive again. You want to know what the probability that Stirrup wins the lottery is? 0. Want to know why it's 0? Because I won't buy a ticket. Very good. What's the probability of any of your family members winning the lottery? There might be a chance if they purchase a ticket. Each ticket you buy increases your probability of winning. Unfortunately, the probability of winning the lottery, if you picking a certain amount of numbers that are flown around in a bucket and drawn out one at a time, that you satisfying those numbers correctly is very low. Could somebody win? Yes. Do people win the lottery? Yes. They are really lucky. Okay? If you won the lottery once, I would say don't ever play again. Don't waste your money. You've won the lottery. Though, I did know in Arizona when they first opened the Arizona lottery, I think it was 1985, a girl in my high school, her family won the $1 million jackpot 2 times in 1 year. That's a lucky family. That's a lucky family. I don't know how they would have gotten that, but that's lucky. Okay? So now I know a person whose family won twice. Does that mean that I have a better chance of winning because I know somebody who had? No. Those balls that come out of that thing to be selected, take place. All right. The probability is set up as a ratio, and you have number of successful over total number. Okay, that's just a fraction. You can make a fraction a decimal. Make a fraction decimal, you can turn your decimal into a percent. Pretty simple. So let's talk about a pretty simple event. Let's talk about flipping a coin, a fair coin. We have an outcome of heads. We have an outcome of tails. Now let's take off the table. You flip a coin and it lands right on its edge. Okay, I guess that could happen. And I know some of y'all did that, you flip the water bottle thing and you get it to, land upright. So weird events can take place. But I could give you guys all a coin right now, and I won't because I don't have any with me. I'm sorry. But we can sit there and flip coins and let it land on the floor. And unless your coin lands on the edge of your desk frame, it's going to fall on the head side or it's going to fall on the tail side. During games when they do the coin flip, football games, soccer games, things like that, to figure out possessions. I've yet to see a coin flip happen and it lands upright. It's like, oh, look, it's straight up and down. Now, it might have happened. I'm just saying I have not witnessed it. Okay? Now, I've seen the referee flip the coin and the team calls heads and it says, tails it is. And so the referee made the mistake. But, so those are some events. So if you flip a coin once, if you want to know what the probability of getting a tails would be, you have one outcome out of the 2 outcomes. 1 out of 2 is 0.5. 0.5 transpires to 50%. Should you leave things as a fraction? Should you make things a decimal? Should you make it a percent? Yes, yes, and yes. Okay? Any of those answers is 100% correct on showing the probability of an event, in this case of tossing a coin and having it lands heads or tails. So probability of tails, 1 event out of 2, 0.5, because if you go 1 divided by 2 on a calculator, you get 0.5. 0.5, if you multiply by 100, you get 50%. Okay? All right, they do have if we had a calendar, and we put all 365 days as pieces of paper, and we start mixing around those pieces of paper, and each one of the days has January 1st, January 2nd, January 3rd. It has something like that. It has all of the days written on it. What would the probability that we draw a January date? How many days are in January this year? 31, right? Count your knuckles. Top knuckle, 31. Bottom knuckle, not 31. Okay? You guys never knew that? January, 31. February, not. March, 31. April, not. May 31? Huh? Not 31. It could be 30 unless we're in February, and then it could be 28 or 29 if we have a leap year. Right? So, there are 31 days in a year. There are 365 days, or there are 31 days in January. There are 365 days in a year. Okay? On a traditional year. I'm not talking about a leap year. Okay? So you have a 31 out of 365 chance that if each day of the year of 365 days, if each piece of paper has a different label, meaning January 1st, January 2nd, January 3rd, etc., all the way through to December 31st. If we mix those all up, and we want to know the probability that the outcome is a January day, we have 31 outcomes that could be January, so there's a chance. Now, what would the probability of me drawing January 10th? That's today's date, I believe. There's one. There's one January 10th. How many outcomes are there total? 365. Okay? So you have a much smaller chance. You have a much smaller chance that you happen to draw. But you had all 365 pieces of paper floating around in there, and they're all the exact same, and they're not crumpled up like I do when I do raffles. If that gets drawn out, probability I draw a January day out is 31 out of 365. The probability it happens to be January 10th is 1 out of 365. Okay, these are probabilities. I could convert these into decimals. Okay, so some things are going to get more complicated when you have multiple events. Hey, what's the probability that I flip a coin and get a heads, and I roll a set of dice and roll a 3? Okay, so we're going to start talking about that tomorrow. So I'm going to kind of pause here. So a few things to know. We are good with chapter 4. We are good with chapter 4. That was the last chapter of last semester that we did not cover. So you're good for the workbook now. The semester 2 workbook is in bare necessities. Okay? You will need that. You will need that in 2 weeks. Deal? Everyone happy?